So the definition of f comma g is? Excellent. What do I replace this by? So now this says the absolute value of whatever. So the absolute value of 10x minus 3. G comma f, by definition. G of f of x. And I replace f of x by? Good. Now I look at G. G says 10 times whatever minus 3. The whatever is the absolute value of x. So 10? Absolute value of x minus 3. Very good. Any questions for me? Any questions for me? Any questions? One problem and then we move on. Let's suppose we are given, we're asked to find G comp f of 2, and this is problem 46 on page 718. How will I determine this, first of all? What does this represent? Excellent. G of f of 2. And I'm given, these are given in the problem. F of 2 is given to be 7. So then this will become G of 7, and in the problem, G of 7 is given to be 4. These are given in the problem. You don't have to make up anything. Okay, section 12.2. Inverse functions. Inverse functions. When we looked at chapter 8, at the beginning of chapter 8, we looked at 3 different scenarios. This is scenario number 1, scenario number 2, and scenario number 3. Here was the first scenario. These are numbers. Whatever number you want to put in there, it doesn't matter. That's scenario number 1. Here's scenario number 2. And here's scenario number 3. Let's discuss all these. First question I have for you is the first scenario a function?
Yes.
Because for each x, there is only one y. Perfect. Is the second one a function?
Yes.
Wait, which one's the second one?
Sorry. 1, 2, 3. Forgive me. Sorry.
Function.
Is the second one a function?
Yes.
Yes. Each x corresponds to only one y. Is the third one a function? No. So this one we know not a function. Now, the difference between these two is the following. One of the two has a property that the other one does not. And that property is called 1-to-1. 1-to-1, abbreviated, of course, the 1-to-1. And let me explain what does it mean, what it means. So this is a function. Each x corresponds to one y. But also when we go back, each y corresponds to only one x. To this y, only one x. To this y, only one x. To this y, only one x. This function has the property 1-to-1. This one does not have the property of 1-to-1 because when we want to go backwards, this y, I wouldn't know where to go. This y corresponds to 2 different x values. Although it's a function, it's not 1-to-1. Now, why is it so important to even discuss the one-to-one property? It's because a function has an inverse function only if it is one-to-one. Because the inverse function will do what? Will return the initial values. If I apply the inverse function to this value, where will it go? Back to this. If I apply the inverse function to this value, where will it go? To this, and so on and so forth. So this is our first note here in section 12.2. Note, only one-to-one functions have inverse functions. Only one-to-one functions have inverse functions. The other ones may have inverses, but those are not functions. And that's not what we're interested in. We're interested in functions who are one-to-one and have inverse functions. And if you ask me why, it's because the two functions that are the core of this chapter are inverses of each other. That's the reason why we discuss inverse functions here. So if a function is one-to-one, it will have an inverse function. How do I determine whether a function is one-to-one if I only have its graph? And I'm going to graph a few functions, and I want you to identify them because all of them are graphs, are functions that we discussed this semester. Here's one. I'll come back, come back, come back. Okay, first function is this. Which function is this? Thank you. What function is this? Careful. Thank you very much. What function is this?
Quadratic.
Which is x squared. Perfect. What function is this? Very good. So let's say y equals, I don't know, because I didn't graph it through the x. Let me graph this one, which I know it's x, not this one. Okay. What else did we have? I think that's.
There was one where it started on the y-axis.
Oh yeah, of course. Thank you.
Yeah, it's just a square root.
Very good. So knowing all these functions, we would like to identify which one or which ones are one-to-one. So what does the vertical line test say to us?
If it's a function.
If it's a function. Very good. So now, what will this tell us? What will the horizontal line test? Exactly. Is this function for this particular y value, let's say 2, do we get a unique, just one x value or more than one? Is this one-to-one? No, not one-to-one. What about the cube root by the horizontal line test? Is the cube root one-to-one? One-to-one by the horizontal line test. What about x squared, the quadratic function? Is it one-to-one? No. By the horizontal line test, not one-to-one. What about the line? Disregard this one, please. What about the line? Is the linear function one-to-one?
Yes.
Yes. What about the square root? Is the square root one-to-one by the horizontal line test?
Yes.
Yes. Very good. So one-to-one, one-to-one. So if I'm given a graph, I draw the horizontal line test, or I use the horizontal line test to identify whether it's one-to-one. So this function that is one-to-one, this function that is one-to-one, and this function that is one-to-one, all will have what? They will have, here's a note. Let's go back to the note. They will have inverse functions. So the cube root has an inverse function. The linear function will have inverse function, and the square root will have an inverse function. Excellent. How do I find the inverse function? First of all, notation for the inverse function. If the function is denoted by f of x, its inverse is denoted by f inverse. And no, this does not mean 1 over f, and it does not mean f raised to power -1. So we read this f inverse. F inverse. If the function is denoted by g, let's say, what we will denote its inverse by? Of course, it has to be the same letter. So there is a 4-step procedure for finding the inverse. 4-step procedure. Did we ever have a 4-step procedure before for something else?
Function composition.
In this test, just read it. Read your test and tell me, yes, we had a 4-step procedure in
What? I don't know.
We had multiple that were like 5 steps, but
completing the square.
Yeah.
Step 1, we identify the middle coefficient. Step 2, we divided by 2. Step 3, we squared it. And then step 4, we added it to both sides. So, find the inverse function for f of x equals 2x plus 4. First, I have to ask you, is this function one-to-one? Because if this function is not one-to-one, I will say, forgive me, sorry, but I can't find an inverse because this function is not one-to-one.
it's linear, so it's inverse.
Excellent. The answer is perfect. F is linear. F of x equals 2x plus 4 is linear. Therefore, it has F inverse. Perfect answer. Good. 4-step procedure again. Step 1.
Is it the same type of procedure?
No.
Okay.
No, I just wanted to remind you and maybe discussing these things because we are coming closer and closer to the final exam. You know, it brings back memory. So I'm hoping that will help. Good. Step 1. Replace f of x with y. Am I allowed to do that? Are they the same? Do they mean the same thing? Yes, they do mean the same thing. So y equals 2x plus 4. In step 2, interchange or swap x with y. And before you ask, I want to explain. Let's come back to this one-to-one function in which this corresponded to this. I'm going to put some numbers now because instead of saying this and this, let's say 1 corresponds to 3. When I apply the function to 1, what do I get? When I apply the inverse function to 3, what do I get? Correct. So 3 is y for the function, but it becomes x for f inverse. That's why I swap them. That's why I'm allowed in step 2 to interchange. And now the y becomes y inverse, or f inverse, which we will determine in a minute. So how will I write the new equation then? In step 3, I have to solve for y. I'm solving for y because now y will become the f inverse. Solve for y. Can anyone solve this for y? First step. Very good. X minus 4 equals 2y. Finally, y equals? Very good. Excellent. In step 4, this is just a formality. I replace the notation y by what? Inverse. It's the inverse.
Oh,
Now this y is f inverse. That's it. Say it again. If we
ever get an actual number, we try to find it.
only if you evaluate it for something. It's a function. Right. Any questions? Now, I'm continuing with the same problem. I found the inverse. Now, here's the next requirement. Graph f of x, which is 2x plus 4, and f inverse, which is x minus 4 over 2, on the same coordinate system. Absolutely not. They must be different functions. First of all, this one is 2x plus 4, and this one is x minus 4 over 2. They are totally different functions. But something very interesting happens there. That's why I want to graph them right now on the same Cartesian system or coordinate system. Okay. So you already, yes?
Question.
Yes.
This is just a guess, but wouldn't, since it's an inverse, wouldn't that make them just perpendicular lines?
No.
No. Okay.
So here's what happens. So if I have the point 1 comma 2 for f of x, what will be the point for f inverse? Careful. 1 goes to 2. So the point for f of x is 1 comma 2. What will be the ordered pair for f inverse?
2 comma 1.
2 comma 1.
So it's parallel.
No, you'll see in a moment. In a moment, just one moment. I'm so happy you're way ahead of me. Because nobody can say that I'm too fast. That's good. Okay, so it's a linear function. We already established that. So when x is 0, how much is y? Very good. So the first ordered pair you will plot for this function is? Very good. And now when y is 0, you have to move forward to the other side. It becomes negative, and you have to divide by 2. Very good. And the ordered pair is? Careful. Good. I knew you were kidding. Good. So we already have two ordered pairs. Ready? 0 comma 4, correct? 1, 2, 3, 4. And negative 2 comma 0. 1, 2. And I draw the line. Please remember to write the name. I graphed f of x, which is 2x plus 4. I refuse to determine new ordered pairs for f inverse, because you will give me two ordered pairs to plot. Please give me two ordered pairs to plot for the inverse function without even looking at the inverse function. Guaranteed points. Excellent. 1, 2, 3, 4, 4 comma 0.
0, no, negative 2.
0, negative 2. Connect and extend. This is the inverse function, which is x minus 4 divided by 2. Is it guaranteed? Absolutely. That's the concept of the inverse function. So if I have 0 comma 4, for the function, I have to have 4 comma 0 for the inverse. Is that clear? Please say yes or no. If I have negative 2 comma 0 for the function, I have to have 0 comma negative 2 for the inverse. And now I think that I know what you're referring to. Here it is. This line overlaps this one with respect to this line. The same thing here. And this point, where it crosses this line, must be the same. A comma A, A comma A, whatever the number is, right? And it will belong to both. What line is this? It is, they are symmetric with respect to this line. What is this line? Can anyone give us this function which represents this line? Thank you very much. The line y equals x. And we will write this as a note, and that's why what you're referring to. Close. So, indeed, this graph is a reflection of the green graph over this line. So the graphs, and this is our important note here, and you'll tell me or you'll help me write it. So note, the graphs of f of x and f inverse for any function are what? Are the graphs of f and f inverse are, yes, or symmetric, correct, that's the same thing, are symmetric, or a reflection, if you want, with respect to, allow me to abbreviate WRT, with respect to the line y equals x. One more time, the graphs of f of x and f inverse will always be symmetric, or a reflection, if you want, with respect to the line y equals x.
So it'll never move, it'll just widen or narrow.
You know, it will flip.
Oh.
Okay? This point, so that's what Will was saying. He was really saying this, that this piece must equal this piece. This piece must equal this piece. So it's a reflection. So this gets reflected. Like this would be a mirror. So it's reflected with respect to y equals x. Very good. Any questions? Let's find the inverse for other functions. And here is one, problem 30. Any questions on this? Any questions? So the graphs of f and f inverse are symmetric with respect to the line y equals x. Always. Always for any function. So let's say problem 30. We have f of x equals x to the third minus 1. Yes. 728. Thank you. I forgot to mention that. Sorry about that.
Wait, so what are we trying to do with this problem?
Say it again.
What exactly are we trying to do?
The 4-step procedure to find the inverse and then graph both on the same Cartesian or coordinate system. I can skip the graphing because that's a little bit more difficult for this particular function because it's a cube function. I can skip the graph. So let's just find the inverse function.
The third root of x plus 1 equals y.
Yep.
So,
Yep, I think you're right. First step, can anyone dictate the first step, or do you need more time? You want to work on this for another minute or not yet? Or we're done?
you want us to find the coordinates as well?
No, I only want you to find F inverse using the 4-step procedure.
We're gonna go into like
Okay.
F inverse and then going back to
No, just find the F inverse using the 4-step procedure. First step, what do I have to do?
yeah, that's small. No, they replace x plus 1.
Very good. In step 2,
Then you swap x.
good. So x equals y cubed minus 1.
Then you swap the y.
Good.
Add 1 to the
Good. X plus 1 equals y to the third. And then what do I do? Very good, excellent. The cube root to the left and the cube root to the right. So then y equals,
cube root of x plus 1.
very good. So then in step 4, I use
Just
the
replace y with f minus 1.
F inverse.
Okay.
Yes. The notation reads F inverse. Good, that's it. That's all I want you to do. Do we need another example of finding the F inverse?
So that's going to be our final answer for when
That's
we're
your
asking
F
questions?
inverse. That's it. Yep. Do we need another?
Yeah.
Okay, very good.
Kind of see what it's like, right?
Yes. So if you remember, we did not graph this. That's why the book does not ask us to graph. But we can. So let's do it. We know how to graph this, though. So we know that this is, if you want to follow for a second, we know that this graph is the cube root of x, correct? But now what will happen if I want to graph the cube root of x plus 1? I'm replacing x by...
the left by 1.
Excellent. Wonderful. Brilliant. So here it is. So this is F inverse of x, which is the cube root of x plus 1. What do I have to draw right now?
The
And I have to reflect this. Where does this point go? If it's 1, 1, it will be reversed 1, 1.
negative 1.
No. If it's 1, 1, reversed is 1, 1. So it has to be part of both graphs. Where will this point go? Is at negative 1, 0. Where will it go?
0, negative 1.
0, negative 1. Ready?
I mean, she didn't want to put that in.
Oh, it was minus. I'm sorry. Of course it's minus.
Just on that for sure.
Any questions? Do we need another example with finding F inverse? Okay, very good. So let's find the F inverse for 27. And 27 is f of x equals 1/2 x minus 1. So 2 minutes. Let's find the inverse of this function. Can anyone give us the first step?
Replace f of x with y.
Good. Step 1, y equals 1 half x minus 1. Step 2,
Swap variables.
good. So x equals 1 half y minus 1.
Swap the y.
Good. You know me what I would do now. What would I do now?
You would clear the fraction.
I'm an open book. So I will definitely multiply both sides by 2. 2x equals y minus 2. Therefore, y equals, and that's our F inverse. Any questions on this? I claim, with your help, however, that these two functions are inverses of each other. Would you agree? Can anyone give us two functions that are inverses of each other? And I'm coming back to that example in a minute. So here's a function. You have X dollars in your pocket, and I'm giving you 5. Which function did I just create? Perfect. And then I come back and I say, give me my $5 back. Which function I created now? Now what happened when I first used function x plus 5 and I gave you 5, but then I came back and said, I'm going to use function x minus 5 now and I'm taking your money back. What are you left with? Exactly, you're left with x. Because these two functions, what did they do was they canceled their effect on x. First I added 5, but then immediately I removed the 5 by the inverse operation, so nothing happened to x. How will I show, and you can say, but this is good enough. We just determined that this is the inverse. Now I'm asking you to use this function and this function and show that they are inverses of each other.
So x plus 1 equals?
No. So what has to happen? The function composition. Let me use F inverse instead of G. So when we determine this function composition in any direction, first I can say I'm removing 5 from your x, but then I'm giving it back to you. Or I can say I'm giving you 5 and then I'm removing, or I'm taking that 5 back. In any direction. First I'm giving you 5, then I'm removing 5. I'm removing 5 and then I'm giving 5. So what should the function composition equal to if indeed two functions are inverses of each other? Plain x. Excellent. Nothing else. Not x squared, not x to the third, not x over 2, not 2x, not 15x. So this is what it's called, the property of inverse functions. This is the property of inverse functions. So now I'm giving you two functions. I'm giving you f of x, which is 1 half x minus 1. And I'm giving you, now I'm going to call it, let's leave it as f inverse, 2x plus 2. And I'm going to say, please show that they indeed are inverses of each other and you did not make a mistake. What will you do? What will you determine? How will you convince me then that, or convince anyone that these two functions are indeed inverses of each other? What will you calculate? You will determine f comp f inverse. You will determine f inverse comp f. And if in both cases the result is exactly x, what will you say? They must be. Because only two functions that are inverses of each other will cancel their effect on x in any direction. So let's determine f comp f inverse. Ready? So f comp f inverse. Can anyone dictate what is the definition of this? How do I write this?
So,
F inverse.
Careful.
Or it's F of F inverse X.
Exactly. So now I have to replace this by,
The inverse function.
which is,
2x plus 2.
very good. And now I look at f, and f says 1/2 times whatever minus 1. How do I write that?
1/2 of 2x plus 2 minus 1.
So now let's distribute 1/2 inside parentheses.
x plus 1.
Very good. And how much is x plus 1 minus 1? Exactly what we wanted, right? Now let's determine the other one. F inverse comp f of x. How do I write this and what it means? And how do I determine it?
Oh,
F inverse of f of x. I replace this by,
1/2 x minus 1.
very good, 1/2 x minus 1. Very good. And now I look at f inverse, which is 2 times whatever plus 2,
2
parentheses,
1/2 x minus 1.
and plus 2. Very good. What do I get?
You get 1x minus 2 plus, plus 2.
Which is?
2x.
So plain x, nothing happened to x. We applied to x two different functions, and nothing happened to it because those two functions eliminated one eliminated the other, or the effect of the other. So now I can say for sure that f of x, 1/2 x minus 1, and f inverse, which is 2x plus 2, must be, and there is no mistake, what?
Is there inverse function?
Inverses of
Each other.
each other. All this theory, the basic theory, was only for the two functions that are important in this chapter. The exponential and logarithmic. This is what we are going to talk about. And why we talked about the inverse function first is because these two are inverses of each other. The exponential is the inverse of log, and log is the inverse of the exponential. If you'd like to look in your calculator, you will see log, which is log function, and right here in blue, or maybe yellow, I'm not sure how you have it in your calculator, you have 10 to the x. It's the same key. They are inverses of each other. Here's another one, ln, which is another type of log function, and e to the x, because they are inverses of each other, exponential and log. So let's talk about exponential first. That's 12.3. Exponential function. So here's the first question for you. Why do you think that this function is called how? How is this function called?
X minus 1.
Why is it called a square root? Why is this function called, how is it called? Why?
Because you can see the absolute value.
So then there must be something about the exponent of this function. So the variable is the exponent. So the exponential function looks like this. Base raised to a power x. So the variable is the power. This is a fixed number, and it's the base. So the variable is the exponent. That's the reason why this function is called exponential function. Now, here's my next question. Can I raise negative 2 to the third power? What do I get?
8.
Very good. Can I raise 0 to the fifth power? What do I get? And can I raise 1 to the fifth power? And I get 1. However, all these are not allowed for the exponential function, although we can perform the operations. The base, see, the base here is negative, here is 0, and here is 1. Those are not allowed for the base of an exponential function. So b, which is the base, can only be positive. It can be between 1 and infinity, not 1, or it can be between 0 and 1, not 0 and not 1. And now your question should be, why? And my answer will be,
It doesn't change.
nope,
The amount of the exponent.
nope, nope. The base cannot be 0, 1, or negative because this function will not exist. The inverse function of the exponential will not exist. It cannot be defined when the base is negative, 0, or 1. That's the only reason. Okay, so this function will increase the list of functions we know. We just reviewed them. The cube root, the square root, the absolute value, quadratic, linear, right? So this will be a new function, and it will have 2 different shapes. Okay? So one example would be f of x, let's say for this particular, where b is greater than 1, let's say 2 to the x. And here, f of x will be 1/2 raised to the x. Here the base is greater than 1. Here the base is a number between 0 and 1. Any questions so far? And let's graph both. I'm going to graph them in parallel so you can see the difference. Sorry, it's not straight. So here we are going to graph 2 to the x, and here we are going to graph 1/2 to the x. We start with the domain like always. Can anyone tell us anything about what you think about the domain? We're not talking about the base. We're talking about what x can be now. Yeah, so 2 raised to negative 1 is 1/2. 2 raised to 0 is 1. 2 raised to the third power is 8. So what will be the domain of this function, regardless of the base? Absolutely. It's a friendly function. Negative infinity to infinity. Very good. So let's create a little chart for both. I put the domain in the chart as you gave it to me. Perfect.